Hi everyone, and welcome to this Lunch and Learn seminar at KTH. I wish to say welcome both to you that are physically present, but also to the ones who are present online. So, as you know, this event will be streamed, but no one except for Damiano here will be shown in the stream, so just so you know. And my name is Fredrik Anupsson, and I'm the team leader for a part of the e-learning management object, as it's called here at KTH. And it's the e-learning management object is an activity both at the Department of Learning in Engineering Sciences, at the ITM school and the IT department. And together we manage and develop the digital learning environment at KTH, for example, Canvas, and we maintain and also develop the other systems as well. It's okay to ask questions during the seminar. Just raise your hand, and Damiano will give you the word. Try to keep the questions relevant to the seminar, of course, as usual. And if not, we can take them afterwards, of course. And for the ones of you who participate online, you can answer questions in the chat, and people will moderate and raise the questions in this room. And if we get the same questions from several people, we will gather them into one question. If you have any questions regarding things that are not directly related to the seminar, you can email the e-learning management object at e-learning@kth.se. And we have a following workshop after this, and for the ones who signed up for this, we gather like around here, and we go together to this room called Hjärna. But with all that information aside, we can welcome Damiano Ognissanti.
Right.
You're a lecturer at the Department of Mathematical Science, both, which is a shared department between University of Gothenburg and Chalmers.
Right.
And you have the title of the lecture right here.
Exactly. So it's you have two strange words here. The first one is Möbius, and the other one is STEM. Usually, we get questions about those two words. I mean, Möbius is the platform that we use. I will show you how we create content and how students interact with that content during this session. And STEM is an abbreviation of science, technology, engineering, mathematics. It's used mostly in America, and I mean in USA and Canada. And yeah, that's about it. So last summer, this Möbius system generated and graded over 170,000 questions for one of our courses during the summer. And since our teachers have 3 weeks to grade exams in a regular course, we have 40 hours per week, right? So it's 120 hours you need to grade all the exams. So if this course, the summer course where we use Möbius, would be a regular course, it would be impossible to find enough teachers to grade within the 3-week period. And that's the first part of the presentation. I'll tell you about this summer math course, massive online course. I will also tell you about a flipped classroom course that I've held for a couple of years, where I've used Möbius in that setting. And then, if we have time, I have a third hidden part where I'll show more content if we have time, but otherwise I'll show more during the workshop. So the summer math course started in 2007, and since we started, we have had 18,000 students taking the course. So we had fewer students the first summers, and now we have around 3,000 students per year. And the course is entirely web-based. You have the course material online, you have the support online, you have all the assessment online. And we have an extensive course material that is written by our teachers. It's both, it exists both as a PDF, but also a printed copy can be sent to all the students who participate in the course. And we have videos for problem solving, also made by our teachers. And we have support via chat and telephone. And this support is we have our own students who answer the calls and answers in the chat. We also have a forum where the students can put their questions and other students can answer. There are multiple ways to get help during this course. And all the examination is in Möbius and it's integrated in our learning platform. Right now we use Canvas, before we use something called Ping Pong, but it works in both. It uses something called LTI, so as long as your learning platform has an LTI connection, you can send and receive information with Möbius. The course literature, as I said, is written by our teachers, and here's an example. We tried to make it as easy to comprehend as possible, but we didn't want to lose the sense of that it's a university course. We want to make it rigorous somehow. So we want to. It's not structured exactly like the high school math books. It's more text, but still we try to make it easier to understand than other texts. And we have an example of the chat history here. Last year we generated 350 A4 pages of text in the chat when we saved it as PDF. So both the students and our students who help them, the mentors on the course, are very active during the entire course. And then this is only the chat where everyone can see what they write. Then we have the private chats, which is not displayed here. So it's even more text than this. And a student can redo each test in a limited amount of times. So we have 19 tests during the course, and we say that if you pass every test at least once, you pass the course. And the thing here is that we really want them and encourage them to redo the tests, even the ones they passed, because we want them to prepare. This is a course made for students to really be prepared when they start university studies. But each time they redo it, they get an equivalent test, but it's not the same. So we can generate questions. If you look here, we have two different graphs and two different integrals to solve there, for example. And I will show this later on, more examples on content, if you have time. We did a follow-up study. This is just a very simple graph. Usually I get reactions on it because of course we have made assumptions here, but we have a bigger follow-up study that hopefully will be published soon. And if you're interested, I can send information about that later on. But what we wanted to see was if we divided the students who started Chalmers into a group that we call summer math students and non-summer math students, and we then check the grade distribution on the first exam, the first ordinary exam at their engineering program, we see that the grade distribution is shifted to the right for the summer math students. It's not just that we have less students who failed, we also have less students with a 3. This is a grading scale. We have failed 3, 4, 5. We have more 4 and 5s. And of course, people will say that, oh, but it's a correlation, not an implication. It's the people, probably the people that are more interested in university studies and really are who are motivated, who prepares during the summer, and the grade distribution would look like that anyway. But we have done more follow-up, and it seems to hold in some way. What we do is we check their grade from high school. So they have a score from 0 to 22.5. And then we try to sample out students who have the same grade distribution in high school and compare them if they studied the summer math course or not. And it seems to hold still. It's not as an extreme result, but it's still, it's significant. So, of course, that's also hard to say. What does the grade in high school mean, and how do you measure motivation? But that's more or less what we could do. We had some idea that we could send out the test before the summer, then after the summer for the students who did the course and compare, but the problem is that it would be really hard to find the students and make them do the tests, the written tests. So we haven't done it. In Möbius, you can create lectures and tests. So it's not just tests, it's also lectures where you create them in a similar manner, but you have a voiceover, so it looks like a PowerPoint presentation, but you have much more functionality. You can randomize your examples, you can create programs with the Maple language and integrate them so you can ask questions during the lectures, the lecture pauses, and then they can answer. You can check if they understand each segment of the lecture. And you have the Maple programming language in the background, and you can randomize equivalent exercises like I showed you before. And you can integrate Maple Sim, GeoGebra, HTML applications, YouTube, etc. You have more or less, if you have a sensible JavaScript API on your program or web page, you can somehow integrate it in Möbius. It's if we have time, I could show a simple example during the workshop later on how to do that if someone is interested. And you can write mathematics with LaTeX or MathML. Our teachers use LaTeX when they publish articles. They can just start right away. You can't import libraries in LaTeX right now. I've had a discussion with them. I'm not sure if it will be included soon or not, but at least the most common things when you do a normal course works. So you can't do, in LaTeX you can also have packages which help you if you draw chessboards or whatever. I don't think that works out of the box. You can also look at the statistics on questions. So I have 2 questions here, and unfortunately they are a bit blurry. But on the left-hand side, we have a graph with different exponential functions, and they are supposed to tell which one is which. So which one is e to the power of 2x, etc. And when I had my course, the flipped classroom course I'll talk about soon, I saw that 56 out of 58 attempts on this exercise were correct. But on the other hand here, when they have something times sine plus something times cosine equals something. So they are supposed to use to rewrite the left-hand side as a sine with 2 angles added together. And almost no one did pass this. And I also had another example where I had a question that were easier. I mean, the theory was simpler. It was just the intersection between 2 circles, but the answers were in such a strange form that when they inputted it, it was almost always wrong. And so you can use this not just to check the theory or the background of the student, but also to see if you thought your exercise through or not. I mean, if you have hundreds and hundreds of attempts and no one. Probably you did something wrong if no one can solve the exercise. So I'll have to look on this exercise to see, is there something wrong with it? Or do you have to explain it in a better way during the lectures or whatever? And when I had my flipped classroom course, I have 10 days at the end of the summer, and they're supposed to repeat almost all high school math during those 2 weeks. So we have 10 lectures and 10 exercise sessions, or we had it before. And then I said, instead of doing that, let's just take and do video lectures and homework assignments in Möbius. And the idea is that if they watch a video at home before they come to school, so we have a 5-10 minute video for each session where I just explain the basics. Then we can go in depth in the theory session and have tutorials at school, and then when they come home, they watch the next video, or first they finish their homework assignment for that day, and then they watch a video lecture for the next day. And I tell them that it's really important that they do this, because that's more or less how you should do when you have a regular course. You check what are we going to do tomorrow at the lecture, and read in the book or watch some tutorial beforehand, so you know what to do and what to expect the next day. And they had to pass all 10 assignments to be able to write the exam. So I didn't let anyone who just did some of the home assignments go to the exam. They had to pass them as well. That was also a problem. Some students thought that they said they made an attempt on everything, but unfortunately that wasn't enough. I wanted to see what would happen if I forced them to actually do things during the entire course. And the exam was also in a computer room. It was with the same system that I used for the homework assignment, this Möbius system. They had 10 random tasks, one from each home assignment. So each student got an equivalent but unique exam. So first because we have 10 questions for each home assignments, more or less, so we had almost 100 questions. I had almost 100 questions I could select from. So they could get different question types, but also different variables or coefficients in their exercise. So they could sit next to each other, they couldn't talk to each other, but still, we didn't have to worry too much about that. And the system is also, it enters, when you have an exam, it enters full screen mode, so you can't do anything to exit it. If you try, everything locks down. It's even so sensitive that if the screensaver turns on, it locks the system down. So you have to be a bit careful, it's super sensitive. And since the students know it's super sensitive, at least what we saw, they never tried to do anything except just answering the exercises. And we tried to look out for smartphone, because if you know that the computer is locked down, you will try to enter web pages on another device. But they didn't seem to have, at least during these 3 years I've had this course, we have no cases even of someone attempting, at least what we've seen. And they have 2 hours to finish the exam. That was because if they have longer than 2 hours, you have to have a guard in the corridor because they're allowed to go to the bathroom. So we just said that, okay, it's 2 hours and you're not allowed to go to the bathroom, and then it's easier to do multiple sessions during the day. And since they had a unique exam and they didn't know, I told them that I would take random examples from the homework assignments already, so they knew that. So they had no motivation to cheat. So that way we could have multiple sessions throughout the day, and they could just say, I want to turn up on that session and do the exam. And they get their exam and perform it, and then they go home. And they get the result right away. And that was also something I thought was important. It's more or less like when you do the driver license test, that you see if you pass or fail. And I was present on every exam because I wanted to stand next to them when they hand it in. So if the system says, "Oh, you failed," but they are exactly on the limit, I could see if they made some minor mistakes. I looked through their calculations, and I could say if I judge them to pass the course anyway. So it's very important that I'm the teacher, not the machine. And also, I mean, they could have written the right thing, but in the wrong form or whatever. That's also why I wanted them to do the home exercises and pass them before they did the exam, because then they had some practice in using the system, so that wouldn't be a problem during the exam. And when we look at the exam results, it's a bit hard to say exactly what we see here, but the first 2 years, 2015 and 16, was regular lectures with a regular written exam, and then we used Möbius here. And if we just look at the student who showed up at the exam, you can see that the amount of students who passed just went from around half of them to almost all of them. But then, of course, I had less students who showed up at the exam than usually, because I forced them to pass other things before the exam. So I had a high dropout rate. And so you have that if you look at among the registered students, you see that it's not, I mean, 2016, I had a written exam and you had lots of students who passed it anyway, or not lot, but you know how it's with math exams. I mean, we're happy with this. But it seems to have gone up. 2017 was the first year with Möbius, and the results are worse there than the 2 following years, because I've learned from my mistakes, and I know what they have trouble with during the course, and I can spend more time on those things. And if we look at the score, we can see that both among the examinees and the registered students, you see that the score they got on the exam is higher. So, no, this shouldn't be registered. This should be among just the students who passed the exam. So that's why it's closer. So if I just removed all the failed students, because we had lots of students who failed over here, didn't have as many who failed over here. So that's why it's closer. And then, of course, it's hard to say, is it really the same thing doing a written exam with this digital one? Can you compare them? I don't know, but at least it seems like they learn more, but you know how it is when you do follow-ups, you never know if you've thought everything through. We had a query at the end of the course. A quarter of the students answered it in 2007, and they thought this was a really good course. This was the first year I used Möbius, and the thing is that if you look, you see that the video lectures were 77% thought they were helpful, but 91% thought the lectures were helpful. And then you had the home exercise. It seems like they like the traditional lectures more. But the thing is, if I compare with earlier years, they seem to appreciate the lectures more now than before, because they've actually watched the video. I can see if they watch the video or not, and they do. They watch it during the entire course. They also go back and watch this video when they start the courses later on, their regular calculus course later on. So they do watch these videos, and they do attempt the exercises. So I think that since they actually they prepare for the lecture, they can appreciate the setting more. And since we have less students there, we have more time for questions. Because at the first lecture we have 100 students there, and then I say you have to do things during this course to be able to do the exam. So on the second day you have 60 students there, so just a high dropout rate on the first day. So you could say that, okay, I should do something else just to try to keep people in the classroom, and I can try it. But these 3 years I just tried to see what would happen. And we had more time for questions. The students had a dialogue with me. Usually when you lecture, you just speak and no one says anything. You're not sure. You ask, do you understand what I did? It's quiet. And you say, I'm assuming now that you understood what I said, and it's quiet. But now instead, they were just talking like mad. So we actually had great discussions, and some students, when we spoke about sums, and I talked about Zenon's paradoxes, we had a huge discussion about that, and on the axiom of infinity, and they were really interested because they had questions to ask. And I had comparable results on the query 2018 and 19. And it seems like continuous examination creates larger dropouts, as I said early in the course, but it helps them to prepare for the exam better. And since we have a higher dropout rate, we have less people at the lecture, but they are well informed and they have a great discussion among each other and with me. And it's very important that you don't replace teacher with the computer. I told them that they had to understand that I was a teacher. Some students, they emailed me and said, oh, I tried 3 times on this homework assignment. I just can't. And I looked, and they just did them. They wrote the answer on the wrong form, and I'd say, okay, but I've changed your grade, you passed it. So it's important that I do the judgment. I just use this to help with solving all this, because they have, in this course, they also had an unlimited amount of attempts on the test. I really wanted them to redo them over and over. That's more or less it. I will leave this on for a bit so you can see. We have some more time if I can just check, are there any questions? Because if we have questions, perhaps that's better to do them before. Yes, we can see here. You had the box. Perfect.
Yeah, thank you. Is anything to switch? Oh, it's right on.
Yeah.
Yeah, you said that when the students have submitted the exam and they are not satisfied, or at the end when they are submitting, you are there to check.
Right.
And so how do you check? Because what information they input to the system? Because they writing any intermediate solutions, or if the final answer is not correct? And could you
Absolutely,
explain
I
how
understand.
you,
Yeah, I understand. How do I know what mistakes they made during the exam?
exactly.
So the thing is that we just ask for the answer in the computer, but they have their papers to write on during the exam, and what I do is I have a password protected page when they hand in. So when they try to hand in, everything freezes and say, now you have to call the teacher. I go there, I take their papers so they can't mess with them afterwards. I input the password, we see the score, and we see all the questions and answers, if they got correct or incorrect, and I also select that I want to see the correct answer all the time. So I see whether they did a correct or an incorrect attempt, and then if something is incorrect, I can check their calculations. And since I just have to check for the students who almost passed the course and who say, oh, I really think that this one is correct, or oh, I see if you see that this is this is an equation, they inputted 2 roots, one is correct, but the system says just one, they inputted probably the false root, you can just check the calculation and say, okay, maybe this is half a point, even if you can't get it on the exam. You check, you try to make a judgment. So that's how I do it. Exactly, but other teachers have an idea, because this is just applied question, or where you do calculations. Probably, if you have other courses, you want theoretical questions as well. What you could do is that you have all questions inputted into the computer system, and they answer everything. And the ones that the computer can grade, the one where you do calculation and enter an answer, you get the score. But on the theoretical one, they show on the screen as well, but you don't get them graded, and they hand in. So instead of grading 10 questions, you grade two theoretical questions, and the other, something like that. So that works as well. It really depends on the focus of the course.
Yes. You said that continuous assessment would increase the dropout rate. I guess then that this course is not mandatory.
Exactly. No.
Thank you.
Yeah.
Thank you. So do we have any more questions right now?
Thank you. Always nice to have Chalmers folks presenting at KTH. Very welcome.
Thank you.
Thank you for the presentation. Touching upon the previous questions, you have not tested this concept in mandatory courses, or have you?
Not yet. We're doing it in a course right now that we have computer exams for, but that is also it's a preparatory year that you can use to get into Chalmers, and we have computer exam during the course for just arithmetics and all these things, that how to simplify expressions, and then they have a written exam at the end. So that's now we're trying on that, and on other courses we've used it for many years, but only as these tests that give bonus points for the exam, and not. And this was the first attempt to try it out in a setting where
Do you know if any of the engineering courses are using Möbius?
Absolutely.
They are?
Yeah. We have it in we have 2 campuses. One is on Lindholmen, which is where they have all the the ones who study to become captains for ships. How do you say? Captains, yeah. And they use the system as well, because they have lots of simulations and things that they need to, and they are integrating this system. So they have maps with where they test them on all things. It could be either the like weather forecast, or they use it for just answering theoretical questions where they have multiple choice on different rules at the sea. We also use it we have started using it in physics, chemistry. We use it in marine sciences. So we use it in multiple departments.
Actually, it's commonly accepted, you mean, all around Chalmers?
Yeah. And it's spreading since,
courses.
yes. Of course, the first focus was mathematics, since it's easier to create these questions.
Yeah.
But now we also have in statistics courses, of course. But then now we have expanded into other fields as well.
So you're using Möbius from 2015, if I understood correctly.
Right. Before it was called Maple TA, so I said 2007. The department started using the software before I even started university.
So the concept is not new. You have been using another tool before.
Exactly.
That's where I'm.
That evolved into Möbius. So this Maple TA was the first product that just had tests, and now with Möbius you can also create video lectures, and you can do more complicated things, more advanced things.
How complicated is the big question?
It really depends on your programming skills.
Relatively speaking,
yeah, I mean, I've seen examples where you have the solar system, and you have the planets on the side, and you drag and drop the planets in the right order just to see, and then you say grade, and it says if it's correct or not. So you don't need to have an input box. You can have. I've seen someone integrate in structural engineering. It was in USA or Canada, where they use this system. Is it the Unreal Engine or something online, where they construct buildings and they use some construction tools, and they can implement that with JavaScript somehow. So it really depends on your program skills. You can do really advanced things. We've done. On our courses, we mostly have solved this equation or things like that with a box where you enter your answer, but you have click and drag, you have multiple choice, you have also, you can add these when you solve, when you have in physics free body diagrams, where you draw the arrows and you say that this is the gravity and this is so you can. They are adding more and more, and they are adding support soon for Python programming language, because now it's Maple, and hopefully when they do that, you can do more things.
That would be cool for sure.
Yeah.
Relatively speaking, was it an improvement when you switched to Möbius? Could you do some sort of relativity analysis, how students performed before with the other tool? Did Möbius bring in any improvement?
Oh, I don't know. I mean, the Maple TA tool that we used before, it's from the same company. Möbius is just, they switch names after an upgrade. So you could treat it as the same tool. And I couldn't say if the video lecture part or these more advanced questions helped in any way. We haven't checked that, fortunately.
Yeah. Thank you.
Yeah.
Thank you. I just wanted to say that we are using currently Möbius in some courses at KTH that are mandatory courses, particularly in nuclear engineering course at SCI. We have been using the Möbius for reactor physics for, I believe, 4 years now, for fluid mechanics course for 2 years, and those questions are algorithmic questions with multiple variables, self-generating questions with if, for, and other types of loops that generate random questions for each student. And we have seen pretty much the same results. The thing that's measurably changed is the quality of the questions that the students are asking. So they're not asking for simple things, they're asking for really particular things that they don't understand, because they can reattempt the questions over and over.
And another thing is that you can also, I don't know if that feature is how useful it is, but at least you can create a tree branch structure of questions. There are two things you can do with it. Either you create this tree of questions and you say, if you answer this correctly, you go to this branch and get harder questions. If you answer it incorrectly, so you can travel through to the tree, but you have to create lots of questions to be able to make a tree. You know how they, when you branch out, it easily gets very large. And you can also do that if the student answer in a wrong way on an exam. You can select in that question what happens. So I have an example I will show later on the workshop where you calculate the sum. If they answer it wrongly, they answer it wrong, they get a new question. Is it an arithmetic or a geometrical sum? And they can select between the two. And then they say what is, and if they answer that one correctly, they get a new question just to try to see what their mistake was. If it was a small calculation, which of these formula is correct? For calculating geometrical sums or things like that. So you can do these things also if you try to, but I don't know how effective they are. I've just tried it now once, so I couldn't say.
Do we have any more questions, or would you like to show some examples? I assume you have some.
Absolutely, I can see if we have some time. I can.
Yeah.
Let's see if we go here. If hopefully it will show up. Otherwise, I will here. So either you can use this. Okay, let's see. If we do like this, either you can use the Möbius system for showing all your content, like you have all the video lectures here, and you have the tests here, or you can use your learning platform and just connect it. So they use a link and enter a test directly. And let's see if, for example, we take this one. So the trigonometry lecture. Let's see, and let's see if the sound works for it.
Med många termer och vi behöver därför införa beteckningar.
No, wait, sorry. Not this one. We try this one. Just because what I wanted to show was that when you create lectures, it's more or less like when you create questions. So you write the text like a PowerPoint presentation, you record your audio, you create examples, and then I made an application here. Let's see, and I also try to write everything I say. I know that some students say that it's annoying that you do that, but I really want everything I said to be written as well, so that the student, if the student needs the extra information for some reason, they have it there. You can also add as some sort of subtitle thing as well, but it's here. So this is a program I made where you drag this thing and you see the radians and degrees here. So you can try to get accustomed to how to switch between radians and degrees. And then later on in the lecture, I also have another example where when I've introduced trigonometric questions, I do basically the same, but I just say what the sine and cosine value is for that angle. And that's one way to do it. This is a really simple program, so you use Maple and just drag and drop. So it's nothing fancy here. And you can just still have that the lecture stops, so they can try this out. And then when they click continue, the video continues. And if you create questions here, you can add. Some teachers do. They add like something that looks like exam questions here. Then you can check how it went. You can also say that you have to pass the question to pass the lecture. So you can do, instead of having a 15-minute lecture, you split it into parts. And then I have. And then when they've done, they can just, let's see if I take this one, they're supposed to do some, now took from another part of the course, so, but you see that here they're supposed to solve this inequality. Here they have drag and drop to create the interval. You can use multiple choice. You can also have multiple choice where you have many correct answers. And here's another one with drop-down lists. So these are fairly simple. Another one But then here we have one where you input the answer and you use more standard syntax like SQRT for square root and all that. But you can also use this one. So say if I write something here, I write the square root of x or something. Then if I use this one, I can see that it shows with a better font what I answered and how it's interpreted. And then this other box here opens another thing here with a palette that can help you to input your answer. And so you can have the fractions, the absolute values, the powers, the square roots. And this palette changes depending on the question. So all the symbols you need are shown there, but also other symbols. So if you have, so really, it adapts to the question. So there, and that's, I think, that's, I can see if I can show you, for example, I can show you one thing. If we take this one, you asked if you could do something with HTML. I can try to show you one of the, this is drag and drop, so it's very simple. Here you have these menus. I'll just show you the one. Also, when you draw figures, you can select that it's, for example, this one actually has 35-degree angle here at the bottom. So when you recreate the exercise, the plot or the image can rescale, and that's pretty helpful. So you actually get something that is accurate instead of just drawing a triangle and just say, here, let's see what you have here. This one. Oh, this one is pretty interesting because we use Möbius built-in scientific constant package to generate these stoichiometric equations that actually can happen. So we randomize the elements from and combine them, and then they can calculate all these things here. And then so you can actually, there are built-in things that where we have all these properties you can check. And let's see, the one I wanted to show you was this one. So this one is a simple HTML application where you're going to fill the electron shells. So I did this in JavaScript really fast just to have something to show. But as you see, it works well. You can add and subtract these things like this. And the thing is that when you submit your answer, the state of the program is saved. So when you check, let's see here, this one shows a visual image of what I answered and the correct answer as an image. So you really don't have to think in just text fields. You can actually say that you randomize the element, and when it fills out, it will show the correct one here. It will check if you have the correct answer or not, and all. So you can do more advanced things than just regular text boxes.
I think we're soon running out of time.
Okay.
But I want to thank you for this, and we will, for the ones who signed up for the workshop, we will continue.
Perfect.
Yeah, but I have one question that I was wondering from a bit of an outside perspective, perhaps. But how difficult is it for new teachers to learn this? Is there a steep learning curve? Or?
No, it really depends on the type of question you want to ask. If you want to ask solve this equation, it's very easy to get started, and there's lots of help online and in the tool to get started. Mm-hmm. If you want to do these things, you have to know some more programming. So it really depends, but you can get started right away, and hopefully I will show that during the workshop that you actually can.
Okay. We maybe have one.
Yeah, sure.
Time for one more question if anyone wants to ask that. Otherwise, I think we will thank the Damiano now, and for the ones who signed up for the workshop, we meet a bit here to the left of the table. Yep. So thank you for today.
Yeah, thank you so much.